on centroids, orthocenter, circumcenter and incenter. There are, as you are aware, direct formulas to compute the centroid and the incenter. Of course, we can also have formulas for orthocenter and circumcenter, but many times it will not be necessary. You can go through the fundamentals of straight lines and then knowing the properties of these points of concurrence, we can derive. So I don't really expect students to remember everything through memory. So let's look at this question. But before we start this, a few points about orthocenter. One of the fundamental points is, if the triangle is right angled, then the vertex where the right angle exists is automatically the orthocenter. So this is one thing that all of you can keep in mind. That is one point. And then the next important thing is about equilateral triangles, where most of the points of concurrence coincide. So with this as a background, let's look at this problem. So here we have a triangle with vertices 0, 0, 3, 4 and 4, 0. So clearly it's not a right angle triangle. So we'll have to find out the orthocenter. Now this is the x-axis. So therefore the slope of this line is 0. Now orthocenter is a point of concurrence of altitudes. So from this point you drop a perpendicular. Suppose we call this OAB and this is E. Then slope of AE is undefined because it's parallel to y-axis. But this line passes to the point 3, 4. Therefore, x is equal to 3 is the equation of AE. Now, what about the orthocenter? So you can take this as the orthocenter, which is a point of intersection of, let us say, OF and AE. Now what is the equation of, or rather the slope of OF? Now you can see that AE is perpendicular to the x-axis, therefore the equation of that line will be x is equal to 3. So that's the equation. In other words, if you look at the orthocenter, its x coordinate is now fixed at 3. We only have to look at the y coordinate. So now what you do is, orthocenter is the point of intersection of any two altitudes, let us say AE and OF. So if you can derive the equation of OF, then we can simply solve these two equations and get it. So equation of OF requires the slope, but OF is perpendicular to AB. So let's work it out. Slope of AB is 0 minus 4 by 4 minus 3, therefore it is minus 4. Therefore, slope of OF will be the negative reciprocal of this, so it will be 1 by 4. Right? So what is the equation of OF? Is y is equal to 1 by 4x. Because it passes through the origin, y is equal to mx, its equation. But you already know x is equal to 3. Since x is equal to 3, y will be 3 by 4. So the orthocenter of this triangle is 3, 3 by 4. So as I told you, you don't have to remember complicated orthocenter formulas, but you can simply derive. Okay? Observe the orientation of the triangle and then take appropriate decisions. So here the simplest observation is the orthocenter lies on the line x is equal to 3. So therefore the x coordinate is fixed and y coordinates requires solving the equations of two altitudes. So the correct option for this problem, as you can see, is C. We'll go to question number 2. Question number 2. This is a problem where 3 points of concurrence are involved. We have the centroid, the circumcenter and the orthocenter. One of the important facts in coordinate geometry is that these 3 centers are collinear. That means all of them lie on the same straight line. So this question deals with finding the equation of the line on which the orthocenter lies. So if you can find the equation of the line joining the centroid and the circumcenter, the job is done. So let's look at the data. So we have got circumcenter directly given to us, nothing to worry. But midpoint, the centroid is not directly given, it's a midpoint of these 2 points. So the centroid G is given by a square plus 1 plus 2a by 2, comma, a square plus 1 minus 2a by 2, which is identically equal to a plus 1 whole square by 2, comma, a minus 1 whole square by 2. So now out of the 3 points of concurrence, 2 are already declared. He does not want the orthocenter coordinates, but he just says what is that line on which the orthocenter lies. So let's make that fact clear. Centroid, circumcenter and orthocenter are collinear. This is a very important fact. So what we need is just to find the equation of the line joining these 2. Okay. So orthocenter lies on y minus 0 is equal to slope a minus 1 whole square by 2 by a plus 1 whole square by 2 into x minus 0. So this is the same as a minus 1 whole square x minus a plus 1 whole square into y is equal to 0. And this is shown as option D in the question. So it's based on a very simple principle called the collinearity of the 3 important points of concurrence. Question number 3 is another problem exploring the orthocenter. Now here we got a pair of lines xy is equal to 0. I think the student will recognize immediately as this equation representing the coordinate axis. So if you can write them separately, you will have these 3 equations. The y-axis, the x-axis and the line x plus y is equal to 1. So if you draw a simple sketch to this data, this is the line x plus y is equal to 1. This is y is equal to 0. This is x is equal to 0. Therefore, this is a right angle triangle. And this is the orthocenter because the right angle is here. So there is no discussion, no calculations. Orthocenter is the origin. Correct option for this problem is B. One more question on orthocenter. Now this is a problem based where 2 vertices of the triangle are given. Orthocenter is declared and the third vertex has to be determined. So let's draw a sketch to this problem. For convenience, we'll take A and B on the base, 5 minus 1, minus 2, 3. The unknown vertex will take xy, that's the orthocenter. Right? Now the problem is to determine x comma y. So first what you can do is you can build the equation of, let us say, CF the slope of CF will be the negative reciprocal of AB. So we'll first determine slope of AB. Is 3 plus 1 by minus 2 minus 5, which is minus 4 by 7, which implies slope of CF is 7 by 4. Now you can clearly see that the line CF passes through the origin. Therefore, equation of CF will be y is equal to mx, y is equal to 7 by 4x. Right. Now, there are two ways to approach. The difficulty is, in order to find another altitude, you require the slope of that particular base, which is not available because this is not available. And the next thing is, of course, we can find this equation and that will be perpendicular to the next one. But I advise students at this stage to look at the options. When you look at the options, you will find that one particular option will satisfy this particular thing. So for example, if you look at option number C, which says 12, 21, let us see if when we put x is equal to 12 here, you get y is equal to 21. Yes, because 7 by 4 into 12, 4 cancels 12 3 times, 7 into 3 is 21. So therefore, what we call as option verification says option C is the correct answer. So you can do it more elaborately, but this is a competitive exam, right? So managing time is going to be very, very important. So this does not require any special effort. So therefore, we build the basic equation from where we can test whether an answer is correct or not. But one advice is, because this exam can sometimes lead to multiple options which are correct. Therefore, please look at all the options. Sometimes more than one answer may be correct. In this case, there is a unique answer in the set, which is option C. Question number 5. Now here slightly typical, as you can see, the moment these parameters come, a student is generally worried, but you have to do it intelligently for a competitive exam. Now first let us look at this condition which is given between the parameters. Now you can cleverly choose a combination. Of course, many possibilities are there. So what you can do is, you can choose some T1 is equal to 2, T2 is equal to 1 and T3 is equal to minus 1. Let us see whether this satisfies the condition. T1 plus T2 plus T3 on the left hand side becomes 2, and on the right hand side minus 2 into 1 into minus 1 is again 2. So therefore this combination may be alright. Let us see whether we can do it. Further, you can also make matters simple by taking A is equal to 1. Don't take A is equal to 0, because the entire things will collapse, all of them become the origin. So therefore you must take that precaution. So with this configuration, let us see what is A. Now A will be A into T1, A is always 1, don't worry about that. 2 into 1 is 2, then T1 plus T2 is 3. Then B, T2 into T3, that's minus 1, and then T2 plus T3 is 0. And C, T3 T1 is minus 2, and T3 plus T1 is 1. So we got a slightly simplified particular case of this problem. Well, because T1, T2, T3 are general parameters, it should work for any combination of the parameters. So let us draw this figure and see how it looks like. So let's say this is 2, 3, minus 1, 0, minus 2, 1, right? And orthocenter will be the point of intersection of any two altitudes. Of course, you have to make one investigation whether the triangle is right angled, in which case it becomes very, very easy. Here the question is not to find the orthocenter, but the line which contains the orthocenter. So let's give some names. Suppose this is ABC. Let us call this AD and let us call this CF. Now, what is slope AD? Slope AD will be the negative reciprocal of the slope of BC. Now, the slope of BC is 0 minus 1 by minus 1 plus 2. So, that becomes minus 1. So, therefore, this will be minus of minus 1, which is 1. So, what will be the equation of AD? The equation of AD will be y minus 3 is equal to 1 into x minus 2. So, therefore, you will have y is equal to some x plus 1. Okay. So, that means the orthocenter lies on y is equal to x plus 1 at the moment. Let us also look at one more. Let us look at the slope of CF now, but the slope of CF requires the slope of AB. So, what is slope AB? Slope AB will be 0 minus 3 by minus 1 minus 2. So, therefore, this becomes 1. Therefore, slope CF will be minus 1. What is equation CF? Equation CF will be y minus 1 is equal to minus 1 into x plus 2. Okay. So, y is equal to minus x minus 1. So, y is equal to minus of x plus 1. Now, there is a small confusion, but you have to hold on to the pressure. Y is equal to x plus 1 is the equation of AD, and y is equal to minus of x plus 1 is the equation of CF. What is the point of intersection of these two? That will be the orthocenter. Suppose you solve these two equations. So, if you solve these two equations, because the left hand sides are both y's, x plus 1 is equal to minus of x plus 1. So, when you write x plus 1 is equal to minus of x plus 1, you will get 2 times x plus 1 is equal to 0, implies x is equal to minus 1. X is equal to minus 1, when you substitute in any of these two equations, you will get y is equal to 0. So, minus 1 comma 0 is the orthocenter, but observe the y coordinate, it is 0, which means orthocenter ultimately lies on the x-axis. If both were non-zero coordinates, then we could not predict so easily, but just simply observe y is equal to 0, and that shows that the orthocenter lies on the x-axis. So, option A you can see is a correct answer. Question number 6. Please observe, I am focusing a bit more on orthocenter because among the concurrence points, this is one of the toughest thing to compute. All possible types I am trying to discuss. Now, please observe that we got a triangle whose equations of whose sides are already given. Now, one of them is very significant, y is equal to 0. So, that means the x-axis is holding one of the sides of the triangle. So, this is y is equal to 0. We will call this AB and then C. So, we can assume AC is this and then BC is an x1. So, we want to get the coordinates of all of them in order to get into the calculations. Now, let us take this equation, assuming that this stands for AC, right? If this is the equation of AC, let us see what happens. If you take the first and the last terms and take 36 as a common factor, 37 as a common factor, y plus 36 is equal to 36x. Now, common sense will tell you, let's look at the other equation also. Suppose this stands for BC. We can write 64 times x plus 63 is equal to 63y. I think one small correction we'll do in the data. We'll call this 36x, 37x and 36y, in which case this becomes x and this becomes y. Right, I think this is correct. Now if you look at both these equations, one thing is very clear. If you want to know where AC cuts this line, you put y is equal to 0 in this. So when you put y is equal to 0, x becomes minus 36. Therefore, A is minus 36, 0. The same thing you do here, because this represents BC. Therefore, if you want to know where this cuts y is equal to 0, simply put y is equal to 0 and you will get a B is equal to minus 63, 0. Right? So that makes matters a little bit simple. Right, this is where we are. Now, the point of intersection of these two, AC and BC, should give us C. Right? Now, how to get it? To find C, you solve AC and BC. Right. So solving AC and BC should be slightly difficult given the combination of the things. But meanwhile, let us also look into the location of the orthocenter. Suppose this is CF, orthocenter will be somewhere here, right, on that altitude. Now the slope of AB, as you can see, is 0. Therefore, this line will have its equation as whatever is this x, that will be the equation of this particular line, right. So now, as I told you, the orthocenter, which is the point of intersection of all the altitudes. So let's take this as D, let's take this as E. The altitude CF, we can only get the slope but not its equation. But what is very convenient is we can easily find the equation of AD and the equation of BE. Now the slope of BC is already known to us. Slope BC will come from this particular equation, right? So it is 64 by 63, and similarly slope AC will come from this equation, that will be 37 by 36. So equation of AD will be y is equal to, actually y minus 0 is equal to, the slope of AD will be the negative reciprocal of slope of BC. So minus 63 by 64 into x plus 36. Similarly, equation of B will be again y minus 0, that is y, is equal to the negative reciprocal of the slope of AC. So that is minus 36 by 37 into x plus 63. Now you can clearly see this is the line AD, first one, and the second one is BE. Now if you solve these two equations, you will get the orthocenter. But orthocenter is already declared as A, B. So if I solve these two equations, I will get the values of A and B. So solve to get A and B. A will be 36 into 63, B will be minus 36 into 63. This is for the student to verify. So therefore, the value of A minus B will be 2 times 36 into 63. So let's work it out. 36 into 63 will be 18108, sum 216. So 8, 6, 2 and 2 multiply 2 times. 8 2s are 16, 13, 45. Well, this is the unique answer to the problem. In this JEE type of problems, there are questions where you can have a single correct option, multiple correct options, but there are certain questions where the answer is unique and it's always an integer. This is that type of question. So please watch out. Orthocenter is a critical area to practice. This is a problem which is based on the matching type. You have to be very cautious with this type of questions because there sometimes may not be a one-to-one correspondence. In fact, for one particular question on the left side, there can be more than one correct answer on the right hand side. Okay, now let's look at this. But as you can easily see, this is based on a very, very fundamental level of testing your knowledge. The triangle, if you can see, is right angled. So the moment it's right angle, immediately the student will say the orthocenter is at the corner where the right angle is located. So AB happens to be the orthocenter. So where does it go? C goes to Q. That's done. Next, let's go to the centroid. The centroid will be 0 plus A by 3, B plus B plus 0 by 3. So this will be 2A by 3, 2B by 3. So the centroid goes straight away to that one. Next, when it comes to circumcenter, now this is a very interesting thing which again students I think are familiar. For a right angle, several good things happen. In a right angle triangle, the circumcenter is nothing but the midpoint of the hypotenuse. Now, this is where the circumcenter is located. It is simply the midpoint of this line segment. So, therefore, it is A by 2, B by 2. So, the circumcenter is going there. Well, the only thing is foot of the altitude from C. That means if you take this as A, this as B, this as C, then we are now interested in finding out the foot of this perpendicular. So how to get it? Take this equation and solve, right? You work it out please, because it's not that very difficult. I will give the basic guidelines. Equation of AB will be x by A plus y by B is equal to 1 because the intercepts are A and B. And the equation of let us say some CS, equation of CS will be y minus b is equal to, the slope of this is minus a by b, so it should be b by a into x minus a. So if you solve these two equations, that will take you to this option. So therefore, the foot of the perpendicular will be this one. So this is a slightly interesting question because at least 2 or 3 answers can be predicted without much calculation. But the last one takes a little bit of effort by setting up equations and then solving it. Rather, question number 8. Now here it's again a matching type of question where you'll have to work out on your equations and the knowledge of the important points of concurrence. Now, if the centroid is located at 1, 2, then what will be the equation of the line AB? That means it's a sort of a dynamical situation now. The coordinates of A and B will be shifting according to this data, right? So centroid is 1, 2. So what you do is, you assume for convenience, this is A, 0 and this is 0, B. and compute, I am doing part A first, compute the centroid. The centroid will be 0 plus A plus 0 by 3 and then 0 plus 0 plus B by 3, and according to question this is 1 comma 2. So therefore A is equal to 3 and B is equal to 6. So once you know A and B, you can set up the equation. What's the equation of the line now? X by A plus Y by B is equal to 1. This implies it is 2x plus y is equal to 6. So if the centroid is at 1 comma 2, then the equation of AB should be this one. So 2x plus y is equal to 6. Therefore, A is getting mapped to R. Right? Let's go to the next one. Circumcenter at 1 comma 2. But again, don't miss the point. The triangle is right angled. So therefore, the circumcenter will be here. So when you go to part B, circumcenter is the midpoint of AB. So it is A by 2, B by 2. And this according to question is 1 comma 2. This implies A is equal to 2 and B is equal to 4. Right? So again you set up the equation. So you'll get x by 2 plus y by 4 is equal to 1, giving you 2x plus y is equal to 4. Now 2x plus y is equal to 4 is option S. So if the circumcenter is 1 comma 2, then the straight line AB should have that equation. Right? Then let us go to the third option. We can take anything now. Right? Now if you look at C, it says distance of orthocenter from A and B are 1 and 2 respectively. Now you know orthocenter for this triangle is at the origin. So this is located 1 unit away from A and this is located 2 units away from B. That means the x-intercepts and y-intercepts are 1 and 2 respectively. So if you look at the equation of AB for this context, we are discussing C, x by A plus y by B is equal to 1. This will give us x by 1 plus y by 2 is equal to 1, which implies 2x plus y is equal to 2. So the C option is mapped onto P, right? And that will take us to the last one, the incenter. If it is at 1 comma 1, what should be the equation of AB? And you can easily see that this is a standalone answer. Therefore, we can map on incenter to this particular equation. However, for a student who wants to work it out, then he'll have to do a little bit of calculation. For that, what he has to do is, he has to draw this right angle triangle, where this is A, this is B, origin, incenter is a circle which touches the triangle from inside. So this is 1 comma 1, and use your AX1 plus BX2 by A plus B and AY1 plus BY2 by A plus B equated to 1 comma 1. Determine the values of A and B and then again apply x by A plus y by B is equal to 1. So therefore, the fourth option will be mapped onto Q. So what is that we learned in this question? Once again, right angle triangle. So at least two of them are very clear. The circumcenter is a midpoint of the hypotenuse. Then the point where the right angle exists is the orthocenter. And then of course we have got the centroid, which is very easy to compute. But the slightly time consuming one is the fourth option. But by elimination we can easily map on D to Q. Question number 9. Another question to test your fundamental knowledge on straight lines and the points of concurrence. Under various conditions, now we'll have to find out the value of k. Now look at this problem. Xy is equal to 0 stands for the coordinate axis and 2x plus 3y is equal to k. So if you draw a figure, and if you convert 2x plus 3y is equal to k, will give us x by k by 2, y by k by 3 is equal to 1. So that means if this is the point A, this is k by 2 0. If this is a point B, this is 0 k by 3 and origin, right? Now let's get into each question on the left and see where it maps on to the right. Centroid is at 3, 2. That's what he says. So let's do the calculation. Centroid is x1 plus x2 plus x3 by 3. So you will get k by 6, comma, k by 9, and that's given to be 3, 2. Suppose you equate the x coordinates, you get k is equal to 18, which of course is also confirmed by k by 9 is equal to 2, which also gives k is equal to 18. So centroid at 3, 2 corresponds to k is equal to 18. So these two go together. Alright, so A maps onto R. That's a unique answer. Now let's go to orthocenter. Now you know orthocenter is at the origin. Because the orthocenter is at the origin, it does not matter what the value of k is. So for all values of k, this statement is true. Right? For any right angle triangle, orthocenter is at the point where the right angle exists. So how does it matter what k is? Therefore, when you go to option B, it goes to all of them. It goes to all of them. Now this is one of the things students will have to watch out because of the intensity of this exam. Circumcenter is at 3, 2. Again, circumcenter happens to be the midpoint of the hypotenuse. If that is the case, circumcenter is equal to k by 4, comma, k by 6, and this is given to be 3, 2. Suppose we take these two, it gives k is equal to 12, which is again confirmed by k by 6 is equal to 2. Therefore, k is equal to 12 happens to be the unique answer for the circumcenter. So where is k is equal to 12? Option P. So this goes to that. Now let's come to the last one. So it's going to be a tie. K is equal to 48 or minus 48. Area of the triangle is 192. Look at the triangle, please. The triangle is right angled. So the area is half into base into height. So half into k by 2 into k by 2, k by 3 rather, in modulus is equal to 192. So you will get k square is equal to 4 into 3 into 192. 4 into 3 into 192 is 12 into 16. So this is 12 into 12. So let us write it as 144 into 16. So k is equal to plus or minus 12 into 4. So k is equal to plus or minus 48. So you can see both the options are available on the right hand side. Therefore D maps onto Q as well as S. So this can be again a very fundamental question, but questions like this can give you a lot of confidence in working out higher problems. Now this is a problem based on logical reasoning. Two statements are given to you, and at the basic level you'll have to test whether statement 1 is true or false, statement 2 is also true or false. Then accordingly we can discuss. Statement number 1 says, if the circumcenter of a triangle lies at the origin, right? So circumcenter is at the origin and the centroid is midpoint of the line joining -2, rather 2, 3 . Okay, the statement number 1 which is being made is circumcenter is given to be the origin, and the centroid happens in the midpoint of these two, and the orthocenter lies on the line 5x minus 3y is equal to 0. This is a question, right? This is a statement which is made, right? Let us first discuss the correctness of this. Now, what is G? G is 2 plus 4 by 2 and 3 plus 7 by 2, which is identically equal to 3, 5. Now, what is that we know? Orthocenter, centroid and circumcenter are collinear. That means they lie on the same straight line. So, equation joining origin to 3, 5 will be y is equal to 5 by 3x, which means 5x minus 3y is equal to 0. So, whatever he has made about that line is correct. So, statement number 1 is correct. Now, what is that he is saying about statement number 2? He says statement number 2 is orthocenter, centroid and circumcenter are collinear. So, that is in fact a universal truth. Therefore, statement number 2 is always correct. Statement number 1 we have proved is correct. Statement number 2 is also correct. So, therefore, in these types of questions there are 4 options are statement 1 is true, statement 2 is true, and statement 2 justifies the correctness of statement 1. So, that is correct in this particular case. So, when you write the options, you must go for option A in this case. All the 4 will be declared to you. What are the 4? Once again for your reference: statement 1 true, statement 2 true, statement 2 justifies statement 1. That is option A. Second option will be statement 1 true, statement 2 is also true, but statement 2 does not justify statement 1. Statement 3 will be, option 3 will be statement 1 correct, but statement 2 is false. And the option D will be statement 1 false and statement 2 true. In this case, A is a correct option because statement 2 is justifying the correctness of statement 1. In fact, this 5x minus 3y is equal to 0 can be actually derived, you see, and then however that much effort will not be required. So, for this problem, option A will be correct. So, please do more problems on these logical types of problems because it will make you think what all possibilities.